Hey guys, welcome to another lecture from EcoPoint. And as in the last lecture, we started revising some important concepts related to functions. Let's do that again today. Today we will work on the concept of domain and range. So a quick recap. What is the definition for a function? A function from A to B maps each element in domain A to a unique element in codomain B, which exactly tells us that this definition tells us that there are some restrictions when it comes to the x's that we take or the input or the domain. What is the restriction? So each element in the domain A needs to be mapped. So restrictions like, for example, so if you have a function wherein you have a denominator, your denominator cannot be equal to 0. If say you have a square root function or an even root function, so whatever is inside the root has to be positive. If you have say a log function, so whatever is with the log, that has to be strictly greater than 0, so on and so forth. So these are certain things that you will always have to keep in mind while finding out those valid x's which will produce images, which you can take in the domain. Another concept of importance is range. Range means the set of all fx's. The moment you say range, it basically means what are the values of fx's that you take from minimum to the maximum value, whatever values, everything comes in this set. So when you're finding out range, what you need to keep in mind, you need to keep in mind that you might want to analyze the limits. So limit analysis is something which is very important. You might want to figure out minima, maxima of the function. That comes in very handy. You might, in all this process, also want to evaluate the function, analyze the function thoroughly. So f dash, f double dash, that also comes in pretty handy in this analysis. In order to move a little deeper into it, I'm going to pick up a question. Herein, I've taken a question in which, I have square root, I have logarithm. So I have a lot of things out here to analyze in order to find the domain and range for this particular function. So the function right in front of you is fx equals to log, natural log, x squared minus 4 upon square root of 9 minus x squared. What will be the domain for this function? In order to find the domain, there are two conditions, as you can see. So you need to basically find the conditions on x. We need to find those x which will satisfy all conditions. So there are two conditions. Number one, whatever is with log, that has to be positive. Positive, strictly positive. So strictly greater than 0. So what has to be strictly greater than 0? X squared minus 4. Now, x square minus 4 strictly greater than 0 basically means that x square is strictly greater than 4. Now, when is x square strictly greater than 4? When x is either greater than 2 or it is less than minus 2. In other words, when x is on the extremes of 2 and minus 2. But this is how, you can open it up. Of course, it doesn't mean anything together, but what it means is that x is lesser than minus 2, x is greater than 2. Okay. This is something that I can also represent as modulus. So I can say mod x is strictly greater than 2. When you open this up, again, you will get the same expression. Well, that's number one condition. What is the second condition? The second condition, as you can see, is you have a denominator here. So denominator cannot be equal to 0. Along with that, the thing is that in the denominator, you have square root. In the denominator, what you have a square root and x is in the square root. The fact is that whatever is in the square root has to be greater than or equal to 0. So whatever is inside has to be greater than or equal to 0. But since the square root cannot be equal to 0, therefore, the condition turns out to be that 9 minus x square has to be strictly greater than 0. Well, 9 minus x square strictly greater than 0 means x square is strictly less than 9. And this means that x is between minus 3 and 3. So, I just want you guys to understand how to open up when you have inequality and x square. So this is how you do. Whether it's greater or less, you need to know how to read it. Now, this of course makes sense together because this means all the x's between minus 3 and 3, which can also be represented as modulus x less than 3. All right. Now, you have two conditions. The first condition was here, mod x greater than 2, and the second condition is here. If you combine 1 and 2, what do you get? It gives you that modulus of x should be strictly between 2 and 3. Now try to open it up. Or try to locate it on the number line. So if I now draw the number line, what basically I have is, suppose this is 0, this is minus 2, this is 2, this is 3, and this is minus 3. So what we actually fetch was everything between minus 3 and 3. And what we fetch was on the extremes of minus 2 and 2. So what you clearly get is the common part is this and this. Or in other words, it is same as saying x must belong to minus 3 to minus 2 union. You can't have a common thing, right? So it is union. Either it's here or it is from 2 to 3. All these x's will satisfy the conditions to attain a valid value of this function. All right. So this is your domain. For the same function, pause and try to find out the range. You must actually, whenever you want to find out range, you must try to see what your domain is and accordingly try to see for the range. So go as per your domain here. Your domain is minus 3 to minus 2, 2 to 3. So let me just consider the interval 2 to 3. What kind of values will get generated? Well, a very important analysis, as I mentioned, is the limit analysis under certain situations. So here, 2 is not included in the domain, right? But the function, but x is reaching 2. So as x is reaching 2 from the right side, because it's 2 to 3, so it will be reaching 2 from the right side. So we will say extending towards 2 plus. Observe that. Now with 2, I can relate the numerator. X square minus 4, if you observe, this will be tending towards 0 plus, right? Because around 2, x square will, 2 point something, 2.01, 2.00001 square will be 4 point some 000, something very close to 4, a little more than that. So that minus 4 will give you 0, but a positive side of 0, you can say. That's how we work in limits. And if that is happening, this implies that the log of x square minus 4, the log of x square minus 4 is basically behaves like log of 0, which is minus infinity. So this tells you that as x is tending towards 2, your entire function, you can say that since your numerator is tending towards minus infinity, so entire function you can say, because your denominator will be some finite number. So you can say that the entire function is moving towards minus infinity. On the other hand, as x is tending towards 3, but it will be tending towards 3 from the negative, a little lesser than 3. Now this, x as 3, I can relate it to the denominator, that is 9 minus x square. Observe that 9 minus x square will be tending towards again 0 plus, because x square will be a little less than 9, right? Around 3 from the negative side. It will be a little less than 9. So it will be 9 minus almost 9. So 0 plus. So, of course, the square root of 9 minus x square will also go to 0 plus. And that would imply that fx is tending towards plus infinity. Fx is tending towards plus infinity. Why? Because your denominator is going towards 0. So that means the function is tending towards plus infinity. Now, with this analysis itself, what do you get to know? You get to know that fx is tending towards minus infinity. Fx is tending towards plus infinity. So that means fx is generating values between minus infinity and infinity, right? Fx is generating values between minus infinity and infinity. But what you should do here is you should also do another thing. You have another part to the domain. So consider minus 3 to minus 2 as well. And similar kind of analysis goes in there. So you can say that as x is tending towards minus 3 plus, because it's reaching minus 3 from the right. You can say that square root of, again, 9 minus x square will be tending towards 0 plus. That's in the denominator. So this implies fx will be tending towards plus infinity. And as x is tending towards minus 2 minus, so from the left of minus 2, you can see that x square minus 4 will be tending towards 0 plus, which implies log of x square minus 4 will be tending towards log of 0 is minus infinity. And automatically, that means that your fx will be tending towards minus infinity. All right. So again, what you are getting is that you can say that your fx is tending towards minus infinity and fx is tending towards plus infinity. So you are generating values in between. So from here itself, you will be able to actually say that the range of this function should be minus infinity, infinity. You can also add another insight to this and check for monotonicity. Now your function fx, let me just rewrite. It is log of x square minus 4 upon square root of 9 minus x square, right? So your function is log of x square minus 4 upon square root of 9 minus x square. Now tell me something. For monotonicity, that is increasing or decreasing, well, of course, you can differentiate and figure it out. But I think differentiation would be rather lengthy process in this case. So why not just analyze it? Let's, instead of f dash, let's just analyze. So think about log x square minus 4. Log x square minus 4 is of course log x square minus 4 is increasing because log is an increasing function. Log is an increasing function. So log of whatever, but it's going to be increasing, right? And if you observe square root of 9 minus x square. Now you can differentiate this and figure it out. But square root of 9 minus x square, this will be a decreasing function because you have minus x square out here. So this is decreasing. which would mean that 1 upon square root of 9 minus x square would be actually increasing. And that means log of x square minus 4 upon square root of 9 minus x square will be increasing. So which means that in the respective, in the domain, in the respective domains, that is minus 3 to minus 2 and 2 to 3. This is, of course, a function which is not continuous, okay? But in the respective domains, it is increasing. So it is increasing from minus infinity to infinity. Here as well, graphically you can see, and it is increasing from minus infinity to infinity between 2 to 3 as well. So the range, what are the value of, the function? Range consists of all possible values that are being generated. So all values in terms of y, see, all values are being generated from minus infinity to infinity, which means we will say that the range for this function is entire R. So I hope with this we have been able to, brush up the concept of range and domain, what the restrictions are, what methodology you should actually try out. I hope this will help you guys. Thank you very much. All the best all the time.